study, so I'm not necessarily recommending that you need to use this with your own studies, but please use this subsampling method for this study. So the particle load in samples can be extremely high depending on the sample type. So it's more time efficient to subsample. So if you've ever picked a sample, like we've picked some samples where there are thousands of particles in the sample, asking you to manually extract every single particle would take a really, really, really long time, and it's kind of not feasible or reasonable to ask people to do that. Also, the longer that you're sitting under the microscope, the less well your eyes work, and it's just a lot to ask of people. So to be more time efficient and conscious of the amount of labor that's required for this, we are asking you to subsample in this study. So this is an overview of the subsampling procedure. We take an extracted environmental sample, so it's been separated into size fractions. We then count each size fraction separately under a microscope. While we're counting, we tally all the particles that we find. So we'll tally every green fiber, every blue fiber, every red fiber in a tally sheet. At the back of your first booklet, these are the tally sheets that we used in the SFEI study, so this is just an example to look off of. In the tally sheet, you'll note every single fiber, but you will only physically remove the first 10 of each color category combination. So if you look at this sheet, you'll see that there are columns or rows for black, clear. This one we use light blue to distinguish for this one. So you pick out the first 10 black fibers, the first 10 clear fibers, the first 10 blue fibers from each size fraction, so not the entire sample. You'll use a separate sheet for each size fraction. After that, you no longer need to extract them, but you continue to count and tally them. So what that means is your original sample jar at the end will still have microplastics in it. The Petri dish that you have will only have the first 10 particles of each color category or color morphology combination for that size fraction.
Are they standard size fractions?
Yes, for this, so there's a small range for this because the sieves that people have in their labs will be a little bit different. So the first size fraction is 300 to 350 microns. So you'll capture in that sieve everything that's larger than 300 to 350. Then we have somewhere between 100 and 150. So in our lab we use 125. So that'll be your second size fraction. And then we have filters for the two smaller size fractions. So we're using a pore size of 20 microns and a pore size of 1 micron. So for most extraction methods, again we'll go into this in a minute, you'll have like 4 end products, so 4 size fractions. From each size fraction, you'll physically extract the first 10 of each color morphology combination and just count the rest. So your tally sheet will have the total number of all particles, but your picked particle dish will only have the first 10 from each color morphology size fraction.
And you're only picking off of the 2 core size fractions.
Probably, so we're not giving you, we want to see how different labs handle the different size fractions. That's part of what we're looking for in this study because we don't necessarily have a best answer for the 2 smaller size fractions. We're not telling you in this course or this workshop specifically how to count the smaller size fractions. I would imagine that you will not be able to physically pick the particles that are on the 20 micron or the 1 micron filter. You may get more, you'll may get more insight for how to handle these when we do the second workshop if you're coming to the instrument training, because there'll be discussions about how to use Raman, how to use FTR, and discussions about automation. So it might be an automated counting system. You may try to visually count them. You might take an image of them and count from the image. That's up to you to decide. This manual extraction will probably only be for the 2 larger size fractions, and you'll have to let us know where that falls off for you. So if in your lab you don't have access to a high resolution microscope or not so great with the manual dexterity, you might not actually be able to physically extract some of the 100 micron particles either.
I used to do polymer analysis, which is almost as maddening as this. With counting hundreds and hundreds of different particles, would use a panel of mechanical click counters.
Yeah.
Do you do that as well?
Yeah, so we do that in our lab, but it gets complicated when you're trying to track color as well. So we're trying to note how many white fibers you have versus how many gray fibers, how many green fibers, but then also all those same colors for all the other morphologies. So if you have a mechanical counting system that works for you, that's great, and use it, and then just fill in your tally sheets if we end up going with the tally sheets for this study, and also provide that. But yeah, that
It's
can
hard,
be a lot
it's hard
easier.
to block that out for
Yeah.
hundreds of CDs.
It is. Yes.
So I'm concerned about the buoyancy of particles because if you're just choosing the first 10 particles, you're probably going to be getting particles of polymers that float rather than the ones that are not buoyant.
Yeah, so if you're doing that, you can, for the wet picking, you can mix your sample right before you take your spoonfuls, which is a great idea not to bias for buoyancy. And also, we've separated it into size fractions, so hopefully the size fraction separation will help avoid the size bias as well. That's one of the reasons that we're doing it, because if we didn't separate it into size fractions, your eyes would probably be drawn to the largest particles first, and we're trying to avoid that. It's also 10 particles for each color morphology combination, so you could end up picking up well over 10 particles for each morphology because you're separating into colors too. So it might not seem like you're picking out that many particles, but it will be several. Because it's the first 10 blue fibers, first 10 white fibers, first 10 black fibers, and so on. Okay, any more questions about subsampling?